All right, we got a special one, a couple special ones coming up here. I'll let you figure that out. Right, so we're still talking about linear equations. And, um, all right, we got 13x. Let's get this up on the board before the sun goes down. Is equal to 11x. That's supposed to be an x there. Plus 5. That's where x marks the spot. Yes, this is a very special equation. Um, okay, so remember like terms? Remember all that? What like terms were? These are like terms. Okay, both have degree 1 here as the variable. Um, we can add their coefficients. So 13 and 9 added together gives us, what does that give us? 22. 22x is equal to 11x plus 5. Now we need to get all our like terms over to one side of the equation, and we're going to do that by, I guess we'll use a different color here. We're going to subtract 11, x from both sides. Not 11, but 11x. So you see this 11x minus 11x, that's going to cancel out to 0. And so now we have a negative 11x plus 22x is going to give us 11x is equal to, and of course these two terms cancel out, and now we're left with a 5 on the right hand side. So once again, we're going to multiply through by the reciprocal, 1 over 11, the reciprocal of 11, which is 1 over 11, because 1 over 11 times 11 is 1. Right, and so we're going to be left with x is equal to 5 elevenths. 5 elevenths. Right, 5 times 1 over 11 can be written as 5 over 11. Now remember how we check our work. We can take that 5 elevenths and plug it in, substitute it back in for x up here, so you'd have 13 times 5 elevenths plus 9 times 5 elevenths. Alright, that left hand side should be equal to the right hand side if you plugged 5 elevenths in to this x right here. Okay? Alright, so we are getting it down now. Getting it down. Well, what's going on here? We need to cut it out. Cut that out, they said. Alright, let's see. We got time to work another one real fast here. Okay, we got 7y plus 18y plus 9y plus 6 is equal to 6 plus 9y plus 19. Alright, so we want to isolate this y. I want to get it by itself. Let's look. We got a bunch of like terms over here, right? These are all like. They're all like. They like each other, I guess. Alright, so 7 plus 18 plus 9 is, oh Lord, what is that? Let's see, 20, 5 and 9 is, oh man, 30, 34, is that right? 34, I should have this stuff worked out. 34y, 34y plus 6 is equal to, we got any like terms? Look, here's two like terms right here. 6 and 19 are like terms, so that's going to be 25. So we got 9y plus 25. Okay. Let's take let's take this 9y over to this side. That means we're going to subtract 9y from both sides. And of course you subtract 9y from this side over here, and we just get 0. So we're subtracting 9y from both sides. So I'm going to go ahead and rewrite this right over here. So we have room 34y. We're subtracting 9y from both sides. I guess I'll go ahead and write it. I wasn't going to, but I need to. Right, and so now we have 34 minus 9. See, these are two like terms once again. So we just add their coefficients. 34 minus 9 is 25. Y plus 6 is equal to 25. And now we could subtract 6 from both sides. Right, subtracting 6 from both sides, we end up with 25. Y is equal to, is that 19? Yeah, 19. Okay, let's see if we can scroll the screen a little bit here. Alright, so once again, I guess I'll just use a different color. We're multiplying both sides by the reciprocal of 25 here. Right, because we've got to get a 1 in front of that y. So 1 over 25 times 19. Alright, so the reciprocal of 25, multiplying it by its reciprocal, you just get 1. And I'm not going to write this. You know what? I should have changed color. Y is equal to 19 over 25. 19 over 25. So that's going to be our solution. And of course, I don't think I wrote it in the last problem, but I'm writing it here. I don't know. Right, our solution set consists of 19 over 25. And if you went in and you plug that back in to these y's here, 19 over 25, and did the arithmetic, that left side should be equal to the right side. All right. Okay, that's going to end this session, and we'll move on to work in some more examples.